Hello everyone. In the series of learning aerodynamics, let us see more about drag polar. In the previous class, we have seen how to derive the drag polar equation, and also we have seen how to obtain the drag polar curve. That means drag polar on the plot. So that is nothing but CL versus this is CL and CD. So this is what drag polar plot, and we have seen how the actual drag polar equation looks. So because the drag polar equation is the combination of all three drags, that means parasite drag, wave drag, and induced drag. All the three components, all the three drag components are included in the total drag equation. And then if you include or if you consider all the drag components, then our final equation will be like this. This is what actual drag polar equation, because we know what is the k1, k2 and k3. K1 is nothing but proportionality constant that comes from the incremental in the parasite drag coefficient. So and then k2 is based on the wave drag, that is nothing but based on the compressibility effect, and then k3 is based on the induced drag. So this k1, k2, k3, if you are taking into account, and then if you are expressing the total drag equation, then final equation will be like this. This is what actual drag polar equation. But if you consider everything, then our curve, this won't be like purely parabolic, because in the CD versus in the drag polar plot, this curve is like it's nothing like a parabola. So this is actually we are considering as the parabola. This one, this curve actually we are considering as the parabola. But if you take all the components of the drag, and then this curve, really it won't be a parabola, or it won't be a pure parabola. So that this will be distorted. It means because of the compressibility effect, mainly the compressibility effect will distort the this curve, the nature of the curve. So it won't be a pure parabola. So then that case, how to find out the our this CL versus CD? Especially by using this curve, we are finding one important parameter, that is nothing but L by D max. So L by D max we can find out by using the minimum drag condition also, and by using this graph also we can find out. By using the drag polar plot also we can find out the L by D ratio, maximum L by D ratio. So that is this is what real L by D ratio, or we can say actual representation of the L by D max. So that is we are getting from this curve. So because the same plot only here we have redrawn, and then from the origin, if you are drawing the tangent to this parabola, or not a pure parabola, to this curve, then we are getting the intersection point, that where it touches. So that point we are taking it as the maximum L by D ratio. So this is what we can say pure or actual L by D ratio, maximum L by D ratio. From the theoretical aspect also, we know how to find out the L by D ratio or maximum L by D ratio. That we will see in the next class or next video lecture. So I hope how the drag polar equation plays the major role in defining the this curve, and also how it is getting deviated, or slightly it is getting deviated because of the compressibility effect. So that we need to understand. Because of the compressibility effect, we are just this curve is slightly deviated. It is not purely parabola in nature. So that thing we have to understand. If you are omitting this component, and then omitting this parasite drag, and incremental in parasite drag, and incremental in the wave drag component, then this we will be considering only this equation. That means we will be having only this. So this is what we used to have. So if you are omitting these two components, that means this parasite drag, incremental in parasite drag and incremental in the wave drag component, then the final equation, drag polar equation, we can take it. Simple drag polar equation we can take it as it is. Means you can say it is CD naught plus CL square by pi E AR. So we will see more about or how to use this drag polar equation in the analytical calculation, or and how this drag polar equation is helpful in analyzing the performance in the upcoming classes.